Hello, this is Kocherla Ramu, SAPS, ZPHS Seethamukala, Prakasham district. Sound is a form of energy like light energy, heat energy. Sound is a form of mechanical energy which produces sensation of hearing. History of sound. Pythagoras at that time he thought that sound travel in air due to the to and fro motion of air particles. In the above picture you can see the to and fro motion of air particles to the receiver. After that, the scientists Galileo and Bacon agreed the theory of Pythagoras. After that, the famous scientist Sir Isaac Newton given the good concept. He is the first person to explain the phenomena of propagation of sound. Production of sound. Any vibrating body or an object produces sound. Here, vibrating tuning fork produces sound. Tuning fork is an acoustic resonator invented by British musician John Shore. Propagation of sound. We all know the bell jar experiment. In this bell jar, vacuum is created and we can see the bell ringing, but we cannot hear it. In the adjacent bell jar, air is there, and in that we can see the bell ringing and also we can hear it. From this, we can know that for sound propagation, medium is required. Medium is a material or a substance through which disturbance is transmitted. Here you can see a wave machine in which you can see both longitudinal wave and transverse wave. Types of waves. The waves are classified into two types: transverse waves, longitudinal waves. In this picture you can see both type of waves. The above one is transverse wave, comprises of crest and troughs, and below one is longitudinal wave, comprises of compressions and rarefactions. In the above one transverse wave you can see the particle vibration direction and wave direction. So wave direction is perpendicular to the particle vibration direction in the transverse wave. In the below one longitudinal wave, the particle vibration direction and wave direction are parallel to each other. So wave direction is parallel to particle vibration direction in the longitudinal waves. If you go through the examples of transverse waves, waves produced in water pond, light waves. Example of longitudinal wave is sound wave. Characteristics of waves. You can see a transverse wave with mean position. One of the characteristic of wave is wavelength. It is the distance between two consecutive crests or two consecutive troughs. In case of sound waves, distance between two consecutive compressions or two consecutive rarefactions, denoted with the letter lambda, measured in meters. Another characteristic property of wave is amplitude. The maximum disturbance of particles in the medium on either side of mean position. In case of sound wave, the maximum variation in the density of medium in which sound wave is propagating. denoted with A measured in meters. Characteristics of waves. Another characteristic property is time period and frequency. Above you can see an oscillation. The time taken to complete one oscillation or one vibration is called time period, denoted with the letter T, units seconds. The number of oscillations of the density of the medium at a place per unit time is called frequency, denoted with the letter nu. Time period and frequency are related by the formula T is equal to 1 by nu. Another characteristic property is speed of the wave. Distance travelled by a wave in 1 second is called speed of the sound wave. Generally, it is related V is equal to nu lambda. Types of sound waves. Musical sounds, noises. Musical sounds produce pleasing effect on the ear. Example, A.R. Rahman music. Noises produce unpleasant effect on the ear. Example, traffic sound. Characteristics of sounds. Pitch distinguishes between shrill and growling sounds, depends on frequency of the sound wave. Greater is the frequency, higher is the pitch. Example, bats make high pitch sounds. Another example, lion roar with low pitch. Another characteristic of sound is loudness. It tells the degree of sensation produced on the ear. Loudness or softness of sound depends on amplitude. Greater is the amplitude, louder is the sound. It is measured in decibels. Human ear pick up sounds from 10 decibels to 180 decibels. Example, with loud sound. Another characteristic of sound is quality. Enables us to distinguish between the musical notes. Depends on waveform. You can see the different waveforms here. Reflection of sound. Sound from the clock get reflected and received by the receiver. It makes an incident angle of 45 degrees and a reflected angle of 45 degrees. So, reflection of sound follows the same laws as the reflection of light. Here, incident sound ray, reflected sound ray and normal lie in the same plane, and angle of incidence is equal to the angle of reflection. Effects of sound reflection. First one is echo. The same sound which we hear again a little later is called an echo. This is due to the reflection of sound. To hear an echo, the time difference between original and reflected sound must be at least 0.1 second. To hear an echo, the minimum distance between the source and the reflected surface is 17 meters. In this image, you can see the original wave and reflected wave. Another effect of sound reflection is reverberation. This is perceived when the reflected sound reaches the ear less than 0.1 second. Due to this reason, original sound and reflected sound waves tend to combine, results in reverberation. Excessive reverberation in an auditorium and big halls is highly undesirable. In this image, you can see the person listening to different sounds known as reverberation. Uses of multiple reflection of sound. Megaphone and a horn. In this video,
6, 7 తరగతుల విద్యార్థులు ఇంటికి వెళ్ళిపోవచ్చమ్మా. ఈరోజు 6, 7, 8 తరగతుల బాలబాలికలు ఇంటికి వెళ్ళిపోయేసి సోమవారం.
You can see a megaphone. These instruments send sounds in a particular direction without spreading in all directions. Examples: megaphones, horns, trumpets, shahnaai, etc. Stethoscope. In this image you can see a stethoscope used to listen sounds produced within a human body like heart and lungs. In this, heartbeat reaches doctor's ears with multiple reflections and amplifying the sound. Range of hearing. Human ears are able to hear sounds of frequency ranging from 20 Hz to 20,000 Hz. Range of audibility is 20 Hz to 20 kHz. Humans can hear between 20 Hz to 20 kHz. Sounds of frequency less than 20 Hz are called infrasonic sounds or infrasounds. Elephant and dolphins can hear sounds less than 20 Hz. Sounds of frequency greater than 20 kHz are ultrasonic sounds or ultrasounds. Dogs can hear up to 50 kHz. Bats can hear up to 100 kHz. Applications of ultrasounds. Ultrasounds are high frequency sound waves. They travel along well defined path in gaseous and liquid media. Industrial applications of ultrasounds. Drill holes or making cuts of desired shapes. Holes are drilled using ultrasonic vibrations. Shape of the hole is same as that of the tip of the horn. Ultrasonic cutting and drilling are very effective for fragile materials like glass. Another application, ultrasonic cleaning. Objects with parts located in hard to reach places can be easily cleaned by this method. In the picture you have seen ultrasonic cleaning machine. Ultrasonic detection of defects in metals. Ultrasonic waves detect the cracks or holes inside the metals used by bridges, machines and scientific equipment. Applications of ultrasounds. Medical applications of ultrasounds. Imaging of organs. Echocardiography is the technique in which ultrasonic waves reflected from various parts of heart forms an image of heart. You can see in the image echocardiography process. Ultrasonography is used to image the patient's organs such as liver, gallbladder, etc. It is also used to monitor the growth of fetus inside the mother's womb. In the image you can see the ultrasonography machine. Another medical application is surgical use of ultrasounds. The ability of ultrasonic wave to cause molecules of materials to vibrate vigorously and break them into, that is emulsifying, is employed in ultrasound surgery. Examples: cataract removal. Another example, to break the small stones formed in the kidney into a fine grains. This eliminates the need of perform of surgery. You can see the kidney with a stone. Sonar, sound navigation and ranging, used for detecting and finding the distance of objects underwater by means of reflected ultrasound waves. The device used in this method is called sonar. In this picture you can see a ship acts as a observation center. Transmitter and detector is installed in it, and you can see ultrasound waves released by it. So in this process we can find the depth of the sea by the formula d is equal to ut by 2, where u is the velocity of the sound in water, t is the time between transmission and detected ultrasound waves. Thank you.